In algebra, we need to be able to simplify equations. And one of the ways in we do that is to what we call gather like terms. If I had two envelopes of exactly the same type, maybe they're white, small, A2 envelopes, whatever, I could simply say that I got two envelopes. Rather than saying that I've got an envelope and an envelope, I just put that down to two envelopes. And it's the same thing in algebra. I can't do it if I've got, say, a white envelope and a brown envelope, because I've got a white envelope and a brown envelope, not two white envelopes. I can't do it if I've got a small white envelope and a big white envelope, because if I say I've got two envelopes, then you don't know that they're different. So there are times when we can gather like terms, and there are times when we can't. Look at this example by here. I've got x, remember x represents a value, we don't know what. But we've got x, and I can simply gather that together to say I've got 2x. Let's say if x was the number 3. X plus x, 3 plus 3, is the same as 2x. 2 times 3, 6. Try it if you like with any number, you'll always have the right answer. So if you've got two x's, an x plus an x, and we gather them together, collect the like terms, it becomes 2x. Apologies about the merger by here. So this time we've got 4x plus 2x. So what do we get? Well, 6x. In the first one, there was one lot of x and one lot of x, which meant we got two lots of x. And this time we've got 4 lots of x, and 2 lots of x gives us 6 lots of x. Simple enough. Now we've got x and a y, x plus y. Are they like terms? Well, the variables are different, so they're not like terms. If the variables are different, or a different type, in other words, if the letter is different, then you can't gather them. They're not like terms. So they'd have to stay the same. By here then, we've got x plus x squared. Well, can't we put 2x with 2x squared? Isn't it the same? No, it's not. Like terms are to the same power. So in this case, the first x is to the power of 1. Any number to the power of 1 is itself, x. Whereas the second x is to the power of 2. So they're unlike terms. If you tried it, try if x was 3. 3 plus 3 squared, 3 squared is 9, so 3 plus 9 is 12. If I'd have said 2x squared, 2 times 3 is 6, square root is 36. So you definitely get a different number. So we can't gather these terms because the powers are different on them. X cubed plus x squared. Again, we can't gather these terms because the powers are different. The first one is x to the power of 3. The second one is x to the power of 2. Okay, again, apologise for this number 2 that tries to merge in by here. Complicated procedure, but I'll maybe change it one day. By here we've got xy plus 2xy. So we've got one lot of xy, x times y, and we've got two lots of xy. There's y's in this, and there's x's in this. So can we gather any like terms? Well, as it happens, you can consider these, because they multiply by each other, you can consider, for the moment, xy to be one term. So this is one lot of xy. Here we've got two lots of xy. So we can actually gather them together to make 3 lots of xy. So although there were variables there, we couldn't just do, say, x plus y, but we can gather the two xy's together to form 3xy. So y plus 2xy. Well, this time the y is not the same as xy. So I can't gather those two together. So although there is a y in xy, I should be considering this as an xy, and this is a y. So as a result, I can't gather the two together. This variable is y, and this term is xy. Okay, so in an exam or whatever, you'll be given more complicated. So, this looks difficult, but bear with me, it's not that hard. We have got 2xy plus x minus x squared plus 4xy minus 3x plus xy. One thing to remember, note before I start, is that when you've got these terms, consider the symbol in front of it to be part of that. So if you like, this could be plus x minus x squared plus 4x minus 3x. You can see that I'm using the minus with the term. And there's always an invisible plus in front of the first one. Okay, so first of all, I look at which terms are identical, or are the same type of term, sorry. So separated by the operators, I can see that there's a 2xy here, there's a 4xy here, and there's an xy by here. And what I can do is I can bring those with their operator, with their plus or minus, over next to my first xy. So I change this to 2xy plus 4xy plus xy minus 3x plus x minus x squared. And so this now is 7 lots of xy. Because the minus 3x and the plus x are next to each other here, again, similar terms because they're both x's to the power of 1, I can now simply do minus 3 add the 1, and my mistake by here, this should read minus 2x, and then at the end is a minus x squared. So in other words, this becomes 7xy minus 2x, apologies for the mistake, minus x squared, and there's my answer. So look for the ones that have the similar term, bring them next to each other. In this case, the 2xy, the plus 4xy, and the plus xy are similar terms, and the minus 3x and plus x are like terms. And then simply add up the numbers in front of them. So 2 plus 4 plus 1, an invisible 1 here, gives us 7xy. And minus 3 plus 1 gives us minus 2x. And then we've got the minus x squared at the end.